5-3, graphing radical functions. So when we graph a square root function, we can remember all of our translations from before. So what do I mean? Remember when last semester we would graph something and talk about how it shifted right, left, up, down, all the crazy things. That is still true. That can still happen. So here, that's what we're going to look at today. What does that look like with a radical? So your basic radical function, so square root of x, starts at 0, 0, and it makes a half of a sideways parabola. Okay, what I mean by that is this would have been the other half of the parabola, but not today. So radical looks like that. To save a little bit of time on this video, I went ahead and snipped a Desmos clip. So notice you'll hit the keyboard to get to the radical, which is right here. You type in the function radical x minus 5. This is what it looks like. Notice this point right here is 5, 0. Okay. So that means that my x value starts at 5 and then goes that way forever. So if we write in interval notation, that looks like 5 to infinity. If we write in set notation, that looks like the fancy words x such that x is greater than or equal to 5. Because it starts at 5 and it's all the numbers bigger than that. Notice our range, the y value is 0 and it keeps going up. So 0 to infinity. I did put brackets on both the domain and range because there's an actual point at 5, 0. If I write that in set notation, that's y such that y is greater than or equal to 0. Both ways are correct. Both ways are not necessary, but depending on the type of problem you have will be what you see. So the last part of the question asks, is it increasing, decreasing? If so, where? So where it starts, is it going up or down whenever I go to the right? What's going increasing? So it is increasing forever. It never decreases. So that one's pretty easy. If you memorize the rules, that is awesome. So remember that plus right there means left, and minus means to go right. Right here, plus means to go up, minus means to go down. Okay, so that's a horizontal translation or a vertical translation. And this is still, if there's a number out front, that is still considered a stretch. Could also be a compression if it's a fraction, which our first example is. So notice we have minus 1 there. That means that it goes right 1. Minus 3 means it goes down 3. If I look at Desmos and graph both of them, so this is square root of x, and this is 1/2 square root of x minus 1 minus 3. This started at 0, 0. It now starts at 1, negative 3. That helped me know that it went right 1 and down 3. That 1/2 out front means a compression of 1/2. Okay, vertical compression if we're making sure all of our vocabulary is correct. All right, my domain of the new function starts at 1 and goes to infinity. My range starts at negative 3 and goes to infinity. I challenge you to try writing those in the set notation, which is like we did here and here. Okay, so what if I'm given a picture and I have to write the equation of a graph? Well, this is that square root function. It's now starting here. And let's see, did it go up one? Okay, so it is going to be square root of x. That means it went left 5 and down 4. I guess that should technically be g of x, but whichever, it's fine. This one looks funny. That's because you need to know the basic x cubed graph. So x cubed is like, hey, there's the square root, and there's another half of it, and it looks like that. The middle is 0, 0. So where did this middle go? It went to 0, -2. So that means that it went down 2. Now, these may have a vertical compression, but I will not ask you a question with the vertical compression. So we're only worried about the middle. We're not going to worry about the rest of them to make sure that they're accurate. Okay, just making sure that you can tell left, right, up, and down. The only other one that I would expect you to know is if it's going down instead of up, that means that there's a negative out front. Okay, and that's what we're going to talk about with graphing.